we were discussing about the map stream. In the map stream we have discussed about hash map, linked hash map, and even hash table. And hash map is as a whole, map stream is a collection. Map is a collection which is used to represent a key value pair. A key can be any object as well as value also can be any object. And there is no any rule like the key or the value should be of similar data types. And keys can be nulls as well as values can be nulls in case of hash map and linked hash map. And in case of hash table will not allow keys as well as values as nulls. And there is no order in case of hash map and even hash table, but linked hash map will give in the insertion order. And the key value pairs can be any objects. But if there is if we try to put another key, for the second time, or if you try to put the same key for the second time, the latest value will override the existing value, but duplicate keys is not possible. For any map collection, duplicate keys is not possible. Duplicate values is possible, but duplicate keys is not possible. How the duplicate elimination related to keys will be done means based on the equals and hash code method. Based on the equals and hash code method, duplicate elimination will be done in case of keys. So that's what we have discussed. And by default, except hash table, all the map streams are not synchronized. Hash table is synchronized by default. If you want to make a map synchronized, then we need to go for collections.synchronized map by setting the map. That's what we have discussed yesterday. And there are still two collection classes in the map stream. And what are those classes means? TreeMap and weak hash map. Weak hash map is not that much important, but TreeMap is important. We'll discuss what is a TreeMap and how we need to go with a TreeMap. Now, there is a TreeMap. Now these are the elements present in the key map. There are 5 keys and some values in the tree map. Now the map is representing a tree map. Now let me try to compile the application. Just taking this first time. Just let me import the TreeMap, which is a class in the util package. Okay, now it was compiled successful. Go to the classes. So now, what is the difference between the order that we have inserted and the order that exists in the tree map? See the order. What is the order? Key 2, key 1, 2, 1, 5, 7, 3. But how is the order here? 1, 2, 3, 5, 7. Is it maintaining in specific order? Is it maintaining in specific order? Yes. The keys are sorted in the ascending order. But the order of insertion is key 2, 1, 5, 7, 3. 2, 1, 5, 7, 3. But here the elements are sorted, okay, in the ascending order. Okay? In the ascending order of the keys. Okay? In a tree map, the keys will be sorted. In a tree map, the entries will be, just in a tree map, entries will be sorted based on the keys. In a tree map, entries will be sorted based on the keys. Entry means a key value pair. Okay? In a tree map, entries will be sorted based on the keys. The entries of a tree map will be sorted based on the keys. Now, a simple question. Okay, can we have a null value as a key for a tree map? Can we have a null value as a key for a tree map? No, it's not possible to have null as a value or null value as a key for a tree map. Just because the keys, the entries of a tree map will be sorted out based on the keys. But if key is null, then it will give null pointer exception. So, just because by default the entries of the tree map will be sorted out based on the keys. If key is null, comparison cannot happen and null pointer exception will arise. So, let me make null as a key for a tree map. We cannot make null as a key for a tree map. We cannot make null as a key for a tree map just because by default the entries of the map will be sorted out based on the keys, and to sort out based on the keys should be compared. But if you want to compare the keys should not be null. For that reason, the tree map keys should not be null. So it is giving a null pointer exception. Now, can we have non-comparable elements as keys for a tree map? Can we have non-comparable elements as keys for tree map? No. It's not possible to have nulls as well as non-comparable elements as keys for a tree map. It's not possible to have, it is not possible to have it is not possible to have nulls or non-comparable elements as keys of a tree map. Now, is address comparable? Here, in this case, is the class address comparable? Is the address class comparable or not? Yes or no? No. How you can tell that the address is not comparable? Address is a. Now, are you telling that a class is not comparable? Huh? How you can tell that address is not comparable? What, man? You can leave off. If you are like this, you can leave off. To be frank, this it was a class that we have discussed just 3 or 4 days back. How we can make a class or how we can make a object as comparable? By using how we can make a class as comparable? By implementing with comparable interface. I don't know what you guys are doing or whether you are practicing or not, but this is not the way of learning. How to make an object of class as comparable means by implementing the class with interface comparable. And what are the methods present in comparable interface? What are the methods present in comparable interface? Compare to method is there, which takes one object as an argument. Okay? So now address is not comparable. So what happens if I give non-comparable elements as keys? Will it give a compile time error? Will it give a compile time error now? Address is not comparable, and I have given address object as a key for the tree map. If I give non-comparable elements as key for a tree map, will it be compiled or not? It will be compiled? No. Will it be executed successful? No. At the runtime it will give class exception. If the elements are not mutually comparable, then at the runtime class exception will be arised. Okay? In a tree map, if the keys are not comparable, then at the runtime it will give a class cast exception. Understood? So now will it give a class cast exception? Yes or no? Yes, just because address class is there and address class is not comparable, and address class is used as a key. Now this is a class cast exception. Now let me make the address as comparable. And comparable is the interface that is present in Java dot which package? Line package. And we need to implement the method compare to. What is the return type of compare to? Yes, I'm returning. Whereas just sort the elements based on the door number. So I'm sorting the elements based on the door number. Otherwise, let me sort the elements based on the street name. It's better you can understand. So I'm writing the sorting logic so that the elements, the address objects should be sorted based on the street name. So now will it be executed successful? Now the address object is comparable. If the address object is comparable, will it be executed successful? There is a string class. Okay, the first four are strings. String class is comparable by default. Now even the newly created class address is also comparable. Now will it be executed successful or not? Address is comparable. Even key 1, key 2, key 3, key 5, key 7. String is also comparable. Now will it be compiled and executed successful or not? I have discussed about this earlier while discussing about TreeMap. This will give a class cast exception just because if the elements are comparable, they should be mutually comparable. String cannot be compared with address. How you can evaluate string and address? See, key 1, key 2 is a string. You can compare key 2 and key 1 and evaluate which one is bigger and which one is smaller. Key 1, key 5 can be compared and evaluated. Key 5 and key 7 can be compared and evaluated. And how you compare key 7 and address? Is it possible? No. So it will be a class cast exception at the runtime. So the elements, it's not that only the elements should be comparable. The elements should be mutually comparable. Okay? If the elements are supposed to be comparable, then the elements should be mutually comparable. Okay? Then just we can tell that the keys of a tree map should be mutually comparable. Not even comparable, it should be mutually comparable. So both string and address are comparable. That doesn't mean that we can evaluate the bigger or the smaller by comparing a string and address object. Okay? They should be mutually comparable. They should be comparable as well as mutually comparable. Mutually comparable means they should belong to the same class. The objects should belong to the same class. So we cannot compare key 2 with address. Just because key 2 is a object which is of type string and this is a object which is of type address. But the address object cannot be compared with string class, string object. How you can evaluate which one is bigger and which one is smaller? Okay? We cannot compare. Okay? You cannot compare. Okay? So let's consider like if you compare yourself and a chair. Where if somebody asks you a question that whether you are bigger or chair is bigger, in what perspective? Okay, you cannot compare yourself and a chair. If you want to compare, you can compare two chairs, two tables, two persons. Then it is said to be a perfect comparison. But you cannot compare yourself with a table. If anybody asks you like whether you are bigger or table is bigger means it's not a valid thing. In the same way, mutual comparison is possible, but comparison between objects of different classes is not possible. So The tree map keys should be mutually comparable. They should belong to the same class. The objects of a tree map or the keys of a tree map should belong to the same class. The keys of a tree map should belong to the same class. In the same way, the objects that we add to a tree set. Understood, Sharad? The same way, the objects that we add to a tree set also should be mutually comparable. The objects that we add to a tree set also should be mutually comparable. The objects that we add to a tree set also should be mutually comparable. In the same way, keys of a tree map should be mutually comparable. So now then just tell the street names, how it will be printed. See, now are the elements mutually comparable? Are the keys of the entries mutually comparable? Yes. All are address objects and address object is comparable. Address object is comparable as well as all the keys belong to the same class. Now, what is the order that it is printed? I am asking, just tell the order of street names, how it is printed. Tell the order of street names and how it is printed. First, what is printed? HCU. Just because first uppercase will have lower ASCII value. So first H, then M, then L. Why A should not come? A is of lowercase. You should not tell it is small or big. You should tell uppercase or lowercase. That should technically we should not tell small case or big case. Uppercase, lowercase. Okay. So first HCU, then L Lingampalli, then M Medipatnam, then Amirpet, and then Gachibowli. So likewise, the lowercase will have higher ASCII value. Uppercase will have lesser ASCII value. Okay. Likewise, the elements are sorted. So, as we discussed, this is the order of the elements. Okay. And now let me give but such rules are not there for values. Okay, for a tree map rules will be there only for keys. Okay, in a tree map the values can be null. In a tree map the values can be nulls, or the values can be of different objects, but keys should be comparable. In a tree map the values can be null as well as can be non-comparable, but the keys should be mutually comparable. Not in a tree map, except hash table. Hash table will not allow values as null. Except hash table, all the collections will allow value as null. All the map collections will allow value as null, except hash table. Hash table will not allow null values, as well as it will not allow null keys. Other collections will allow null as a key as well as a value. Even hash table will not allow null as a key as well as a value. But tree map will allow null as a value but not as a key. The tree map will allow null as a value but not as a key. So here null is a value for the first one, but it is allowed in a tree map. The tree map rules will be there only for keys, not values. The tree map sorting rules and comparison rules will be only for keys, not values. Okay? Now let me not make the address as comparable. Then if we don't make the class as comparable, is there any other option to sort that? If I am not making the class as comparable, is there any other possibility to sort that? If address is not comparable, is there any other possibility to sort the address objects? Let me repeat. If I don't want to make address as comparable, is there any other possibility to sort address objects? See, if you want to sort the elements, we need to compare the elements. If you want to compare the elements should be mutually comparable. But I don't want to make address as comparable. Then in that case, is there any possibility to sort the address objects? By using comparator. By using even comparator, there are two ways of comparing and sorting the elements, writing the sorting logic. One way is by making the class as comparable. The second way is by making use of comparator. Okay? Now let me write a comparator. Okay, just what I'm doing is just I'm using a anonymous inner class as previous. Sorry, it's a comparator, right? It's compare method. Understood what we have done? Understood what we have done? Rather than going for another temporary reference, directly I am getting typecasting into person, and directly using the temporary reference itself I am accessing the street name. Dot comparative of directly I am typecasting here, and through the temporary reference itself I am accessing the street name. Maximum we should reduce the usage of permanent references. It will eat up the memory and it will make the objects to persist for a very long time. So at maximum possible we should reduce the usage of permanent variables or permanent reference variables. Unless or otherwise they are mandatory, we should not use the permanent reference variables, just because they will make the objects to persist in the memory for a very long time. So we should reduce the usage of permanent references unless it is required. Okay, if it is not required, then we should use only temporary references. Okay. Now let me make use of address comparator. While creating a tree map itself, we can use address comparator. So while creating a tree map, if you give a comparator, then the tree map will expect the keys of that particular entry. The keys of that particular entry should be of type, it's person, right? Sorry, is it address? Sorry, I need to typecast into address. Okay, I am typecasting into person, which is not correct. We need to typecast it into address. Okay, then what we are doing is, then the tree map will expect that the elements should be sorted based on the sorting logic in this comparator. In the comparator compare method, what is the sorting logic? First we are typecasting into address and we are accessing the street name, and we are typecasting into address and accessing the street name, and we are comparing both the street names, and based on the street name we are comparing the elements. So the tree map expects the elements should be of type address. Now is the address comparable now? Is the class address comparable now? Is the class address comparable? No, it's not comparable. Through a external comparator we are comparing the address objects. Now the class address is not comparable. The class address will be comparable only if we implement the class address with comparable interface, which is there in Java.line package, and override compare to method. But now we are not doing that. We are using an external comparator to compare address objects. Now address is not comparable. We are using the external comparator. We have written an external comparator, okay, to compare, okay, to compare two address objects while sorting.
Finally we are comparing. But finally we are comparing.
But now address or object is not comparable, right? We are using some external logic to compare the address, but address is not comparable. Address is not comparable unless we provide a comparator. Yes. Address class is not comparable and the address object is not comparable here. We are attaching an external comparator to compare the address objects. Okay? Understood? Now the elements will be sorted based on the address objects. 47. Error is expected. What is 7? Simple expected. It is expecting semicolon. Yes, yes, with a new comparator. It's correct, right?
How many
And here also.
last one?
Last?
Last one.
This one? I don't think so.
आपसे पूरा ठीक है सर आपसे पूरा ठीक है
No. Let me try it. Now it is compiled. So now when I execute the application, just it was executed based on the ascending order of addresses which has ascending order of the street names of the address objects that we have given in the comparator. Okay, if you don't want to go for comparable, then we can go for a external comparator, but while creating a TreeMap object itself, we should give the comparator like a tree set. Is it the same like a tree set? In case of tree set, only objects will be there. Entries, key value pairs will not be there. Okay, in case of TreeMap, key and values pairs will be there, but the concentration of sorting only will be there in the keys. Okay, mostly the keys of a tree map and the elements of a tree set are same. The same rules will be followed. The same rules will be followed for elements of a tree set and keys of a tree map. Understood? The same set of rules will be followed for elements of a tree set and keys of a tree map. By default, they'll be expected to be comparable, but if you don't want to make it comparable, then we need to make use of external comparator while creating a tree set or tree map object. Understood? Okay, this is about the tree map. Okay, the tree map sorting doesn't have anything to do with the values. The sorting in case of tree map will be done only in the case of keys. Okay, key sorting will be there and key comparison will be there. It's not nothing. There is nothing to do with values. Okay, values can be nulls, can be any data type, can be non-comparable, it can be anything. But keys should follow all the rules of comparison. Okay?
It's better taking against class comparison.
Uh-huh.
It's better taking external comparison.
No, it will be always better to use a comparator. Why? That we have discussed already, right? Did we discuss which one is better? Comparable or comparator? Comparator is always better. Okay? What's the reason why comparator is better? That's the first thing. Another thing? The first thing is, okay, the base class code need not to be changed. Okay? The base class code need not to be changed whenever the comparison logic is changed. That's the basic advantage of using comparator. Okay? Once this TreeMap is over, just we'll discuss how to iterate the elements of a map. How we can iterate the elements of a map. Okay? Just let's see how we can iterate the elements of a map. Now, what are the things that we have discussed for a set or a list? First, we have discussed all the entities, all the classes of a set and list. Then we have discussed iteration, how we can iterate, and then we have discussed how we can sort the elements, and then we have discussed how to make it thread safe. All those things will be discussed even for a map. First, we'll discuss how to iterate the elements of a map. Then we'll discuss how to sort the elements of a map. Okay, then we'll discuss how to make a thread safe map. Okay, now the first thing is how to iterate the elements of a map. Okay, in case of a set or a list, how we used to iterate the elements of a set or a list? Using iterator. But in that case, a set or a list contains only one object. The set or a list contains only one object as an entry. If the set size is 10, means what are the number of objects present in the set? If the set size is 10, means what are the number of objects present in the set? 10. If the size of the map is 10, means what are the number of objects present in the map? 20. At least minimum of 20. Okay? If the size of the set is 10, means there will be minimum of 10 objects in the set. In the same way, if the size of a map is 10, means there will be minimum 20 objects in the map. One is a key and one is a value. In that case, we have used iterator to iterate the elements of a list or a set. For a list, we have even list iterator, which has some additional features when compared to iterator. But how we can iterate the elements of a map? Okay, that's a big question. Okay, let's see how to iterate the elements of a map. Now, to iterate the elements of a map, we can have three possibilities. We can either iterate only keys, or we can iterate only values, or we can iterate key value pairs. Let us see first how we can iterate the keys, and let us see then how we can iterate only values, and then after we'll see how we can iterate the key value pairs. First, let us see how to iterate the elements of a. Let me make it linked hash map. Let me try to iterate the keys. And in a map, in any map stream, okay, there is a method named keyset. In any map stream collection, there will be a method named keyset. The keyset will return a set of keys. The keyset method will return a set of keys. The keyset method will return set of keys. Okay. Now let me try to print the keyset. Let me make a simple map. Okay, rather than making it a complex map with address objects, let me make it a simple map with strings. Okay. See, if it is address objects means it will be confusing. Let me make it a map as simple as possible with using strings. Okay. Okay, this is the map, and the keyset method of a map. The keyset method of a map will return a set of keys. Okay, the keyset method of a map will return a set of keys. Just let me try to print the values. Sorry, I am creating a linked hash map using a comparator, which is not correct. Only TreeMap can be created against a comparator. Only TreeMap can be created against a comparator, but I am creating a linked hash map using a comparator, which is not correct. Okay, only TreeMap and TreeSet can be created against a comparator. Okay, so I am creating a linked hash map, which is normal. Now, first compile, go to the classes, execute the application. Now, what are the keys available? Key 2, key 4, key 1, key 3 and key 0. Since it is a linked hash map, it is giving the order that we have given. If it is a hash table or a hash map, can we expect the order? Can we expect the order of insertion if it is a hash table or a hash map? No. For a hash table or a hash map, insertion order can never be expected. Okay? So, the keyset method will return a set of keys. If you want to iterate the keys, what we need to do is first get a keyset and create an iterator. How we can iterate the set? Using iterator. Okay. Okay. Every set stream class will have a iterator. So just by using has next, and next method, understood? First we have created a set from the keys of the map by using the keyset method of a map, and then that keyset contains all the keys that are present in the map, and we can iterate the keys using the iterator on that keyset. Understood? Understood what we have done? First, if you want to iterate the keys of a map, first create a set using a key set method of a map. Using the key set method of a map, we are creating a set and we are iterating a set. How we can iterate a set? Using a iterator object. So upon that set, we are creating a iterator object by using the iterator method, and by using hashtags and next, we are iterating the elements. That's how we can iterate the keys of a map. Understood? Now, let me try to compile the application. IT is not there. Sorry, it's key iterator. Okay. It was compiled. Go to the classes. Execute application. So 24130. Okay, the elements 24130. The elements are iterated. Okay, the elements are iterated. The keys are iterated here. The keys of this map are iterated. Now, if you want to iterate the values, then there is a method named values. Okay, the key set return type is a set. The key set method return type is a set, but the values method return type is a collection. The values method return type is a collection. The values return type is the values method is there in the map. The values method of a map will return a collection of values. The key set method of a map will return a set of keys. But values method of a map will return collection of values. The return type of values is collection. The return type of key set is a set. The return type of values is a collection. The return type of values is a collection. So, how we can iterate the values? How we can iterate this collection, values collection? How we can iterate the highlighted collection? Yes, speak out. Can we use iterator for a collection? Can we use iterator for a set? Can we use iterator for a list? Yes or no? Yes. From where that list or set got that iterator method? Set is the interface, a list is the interface. Okay? Is the method iterator there in the list and set, or is it inherited from anywhere? Understood my question? Is the method iterator there in the list as well as set, or is it inherited from anywhere? I told it clearly while discussing about iterator. Iterator method is not specific to list or set. Iterator method is inherited from collection interface to list and set. Iterator method is not there in the list or set. It is an inherited method from the collection interface. So how we can iterate a collection means by using iterator. Like a set and list, we can iterate a collection also using a iterator directly. The iterator method is not there in is not specific to a list or a set. It is inherited from the collection interface. So to iterate a collection, we can use a iterator. So the same like a list or set, if a collection can be iterated using a iterator like this. Once again I am telling that the iterator method is not specific to list or a set, it is inherited from the collection interface to a list and set. So either a collection or a list or a set can be iterated using iterator interface. Okay, so let me try to compile the application. Compile, go to the classes, execute the application. So 3, 4, 5, 6 null. So the values are iterated first, then key 2, key 4, key 1, key 3, key 0. The keys are iterated and then the keys and values are printed. Understood? How we can iterate the keys as well as values of a map? The keys can be iterated through a keyset method of a map. The keyset method of a map will return a set. Values method of a collection or values method of a map will return a collection. So either a set or a collection can be iterated through iterator. Now, can we make like this? Is it possible or no? No? Yes or no? Why it is not possible? Just speak out loud. After map dot? Okay. Map dot keyset is there. Okay. What is? Should you tell it as a keyset open bracket and close bracket? It's a keyset method. The keyset method of a map is there. That's fine. Okay. And then? Okay. Now, what is the return type of the keyset? What is the return type of the keyset? Set. Now, in the set interface, is there interface iterator method? Yes or no? Iterator method is there or not in the set? Set interface contains iterator method. Now, why do you think it is a compile time error? Why do you think it is not permitted? Why did you think that keyset method and iterator method should not be used in the combination? That's why I used to tell, practice the things. Basics are very important. Okay. Now the compiler will think that map.keyset. Map.keyset return type is a set, and is there any iterator method in a set? Set has iterator method, which will return an iterator. That's possible. And values also will return. The return type of values is a collection. Even collection interface contains a iterator method, which returns the iterator. So we can iterate a key set or values directly using a iterator. Just this is how we can simplify the code. Rather than writing unnecessary permanent references, we can simplify the code. Rather than writing unnecessary permanent references, this is how we can simplify the code. As long as possible, we should reduce the usage of permanent references. Okay, so we have iterated the keys using keyset.iterator, the values using values.iterator. What it returns? This highlighted portion will return a set of keys. That set of keys dot iterator. This will return a collection of values. Collection of values dot iterator. Now what we are doing? We are avoiding unnecessary permanent references. Okay. Now how we can iterate the key value pairs? Okay. How we can iterate a key value pairs? Like key set and values, there is a method named entries. I'm not sure entries or entry set. Let me see. The method is entry set. The entry set will return a set of entries, set of key value pairs. The entry set method will return a set of key value pairs. The entry set method will return a set of key value pairs. Done. The key value pairs in a map. The entries or the key value pairs in a map. The entries of a map are objects of entry class. Each and every entry in each and every key value pair. Okay? Entry is a key value pair, right? So there will be an entry. Let's consider the key is key 1 and value is 100. This is the key value pair. Okay? This key value pair is referred as an entry. And entry is also an object of that class entry. Every entry is an object of that entry, and this entry is a class. This is a subclass to mapping class. Sorry, not a subclass. This is an inner class to mapping class. Entry is an inner class to mapping class. Each and every key value pair or each and every entry is the object of that map.entry. Each and every entry is an object of type map.entry. See, the entry contains two things. Let's consider this is an entry object. The entry contains key value. This is an entry. Let's consider like this is the map. Let's consider that the map contains size as 2. Let's consider like the map contains 2 elements. Keys of type string. Values of type integer, whose value is 100. Keys of type string. Values of type integer. And each and every entry of a map, each and every entry of a map is an object which contains 2 attributes. Entry contains 2 attributes. One is key and one is value. Key refers to the key. Value refers to the value. Understand how the map will be structured? Okay? Inside the map we have entries, multiple entry objects. And each and every entry object we have attribute key as well as attribute value. Attribute key will be pointing to the key and attribute value will be pointing to the value. Understood? That's how it will be in that way.
So what is its type? It's a single entry or map of entry? What is its type? Entry or map of entry?
Entry is a class, map is an interface, and entry is a subclass to. It's not subclass. Entry is a inner class to map interface. So while representing, we represent it as a map.entry just because inner classes cannot be referred without the references of outer classes. Am I right? Inner class objects cannot be referred without using the references of outer classes. So, what is the outer class or what is the outer entity for this entry? Map. So, while representing as a reference, we should represent as map.entry. As a class name, the class name is not map.entry. The class name is entry. But that entry class is a inner class to map interface. So, while representing as a reference, we should represent as map.entry. Just because without having the outer entity reference, we cannot refer inner classes. So, entry is a class and map is an interface in which entry is a inner class. So, what I'll do is, then next we'll return a type of object and we need to typecast into entry. And this entry will have get key and get value. Entry has two methods. One is get key, which returns the key value or which returns the object that exists in the key. Get value, which returns the object that is present in the value. Just try to correlate this code with that diagram. You can understand. Understood? Or still we need to have a discussion about this? Have you got it, or still do we need to have discussion on how entry will work? How the entry of a map will work?
What is next method?
The next method returns, see, first iterator pointer will be before the first entry. Okay? Then hash method will check, verify whether there are entries or not. Next method what will return? It will return the entry object. Next method will return the entry object where entry object is a key and then a value. Key will be pointing to this, value will be pointing to the and get key will return this object. Get value will return this object. Understood? Understood? What, Sharath? Got it? See, try to put most of the things in your notes so that you can refer in the future. Okay? These diagrams and all, we cannot have that in the video. So, try to push most of the things in the notes. The hash next, what it will do means, by default, okay, the iterator will act as a pointer. Iterator will act as a pointer to any direction. By default, the iterator pointer will be there before the first position. Now, what the hash next method will do is, it will verify are there any elements after the iterator pointer here. Now, are there any elements? Here we have two entries. And the first entry, second entry. Hash next method returns true until there are elements under the iterator pointer. Understood? Now let's select two iterations that have happened. Now the iterator pointer will be there. Now the iterator pointer is here. Hash next method will return true or false? False. Just because there are no elements after this iterator. So that's why. That's how the hash next and the iteration mechanism will work.
So what you do say iterator? Second
Second one, okay. See, first one is entry and second one is entry. This is entry and this is also entry. Okay? This entry has an entry object. The entry object we have key and value. Key will be referring to the key object, value will be referring to the value object. The same way, this is another entry which has a key and value. This key will be referring to this object, value will be referring to another object. This is how the map will be structured in the memory. Okay? So, let me try to compile and execute this application. Sorry, compile application. 44. Where is 44? So, here we need to have a semicolon. Just compile. Go to the classes. Execute the application. So, here we are giving key colon value. So, by using a entry set, we are trying to iterate both key as well as value pairs. We can iterate keys individually using the key set. We can iterate the values individually using the values, or we can iterate entries, key value pairs using entry set. Okay, the entry set contains entry objects. Entry set contains entry objects, and each and every entry object will have a key as well as a value reference. A key reference will be referring to the key object. Value reference will be referring to the value object.
So as the next method returns an entry type of object. Why do we use type of into map entry?
Just because if you want to execute get key and get value methods, Can we execute directly? See, the next method returns. The return type of next is object. The return type of next is object. Can we do like this? Can you do like this? No, just because the return type of next is object, and in the object class do we have getKey method? No. So, but the intermediate, the object is of type entry. The return type is object, but the internal object is of type entry. So what we are doing? We are first typecasting into entry, and using the reference of that entry, we are executing getKey and getValue. Understood?
Sir, intermediate type is of entry, not
See, not intermediate type, internal object. Internally, object is of type entry, but the reference is of type object. Okay, so here, next method what we will do? If we return an object of type entry. Okay, but the reference of this object will be of type object. So what we need to do? We need to typecast this into entry so that we can make use of the specific method for the entry. Okay. Reverse iteration is not possible, right? See, in a map, the keys as well as entries as well as values will be either a collection or set. In case of collection or a set, is reverse iteration possible? Reverse iteration is possible only in case of list iterator, which is specific to list. But the key set will return a set, values will return a collection, entry set will return a set. For collection or set, there is no possibility of reverse iteration. Okay? And iteration is over. Now, how is a map thread safe by default? Except hash table, the other map implementations are not thread safe by default. Okay? Only hash table is thread safe by default. Hash map, linked hash map, TreeMap, big hash map, these four are not thread safe by default. So, if you want to make a map thread safe, except for hash table, we need to go for collections dot synchronized map. Just we need to go like this. Map equal to collections dot synchronized map. Understood? This is how we can make a map as thread safe. Next thing is how we have seen iteration, we have seen thread safe, and the two things remaining are how we can sort the elements of a map and how we can eliminate duplicates for a map. Now, how we can eliminate duplicates for a set? How we can eliminate duplicate objects in a set? Just if you override equals and hash code method, by default set will eliminate duplicates. The only thing that we need to do is override equals and hash code method for that class. If you do that, automatically set will eliminate duplicates. But can we do that for a list? Can we eliminate the duplicate for a list by overriding equals and hash code method? Can we eliminate the duplicates of a list by overriding equals and hash code method? Can we eliminate the duplicates in case of list just by overriding equals and hash code method? Is it possible? Is it possible? No. List will never eliminate duplicates by default. Okay? Only set can eliminate the duplicates by default. List will never eliminate duplicates by default. Okay? But if you want to eliminate duplicates, for a list, what we need to do is we need to push all the elements from a list to a set, and again from the set we need to push back to list. That's the only way to eliminate duplicates in a list. That I have told in the earlier classes. Is by using just a list, it's impossible to eliminate the duplicates. But as a mandatory situation, if you want to eliminate the duplicates of a list, what we need to do is we need to push all the elements from a list to a set, and then we need to push back the elements from a set to a list. Then the duplicates will be eliminated. That's the only possibility to eliminate the duplicates of a list. Then how to eliminate the duplicates of a map? Okay, that we'll discuss. How to sort the elements on a map, as well as how to eliminate the duplicates of a map. That we'll discuss in the next class. And in the next class, even we forgot to discuss even about weak hash map. We'll discuss even about weak hash map. And that will complete the basic collections. Okay? And once the sorting as well as duplicate elimination in map is completed, then we'll go to this, what we call generics. Okay? And after generics, we'll discuss JDK 1.5 concepts, which will complete core Java. Oh, file handling is there, right? Yes. Good. File handling will take 3 days. Most probably within a week, we'll complete the basic core Java and we'll switch over. All of you know SQL? Please raise your hands, those who don't know SQL. Please raise your hands, those who don't know SQL. Queries. All of you are comfortable with the SQL queries? All of you? Yes? Then we can directly discuss JDBC. Am I right? Without discussing SQL, can I directly go to JDBC? Is that okay for all of you? Yes or no? If it is yes, then we can directly discuss. Okay? Those who don't know about SQL and those who not able to express it here, we have at least 4 or 5 days to start JDBC. Within that time, at least get some basics of SQL. How to create, how to drop, how to alter a table, how to insert some data into a table, how to fetch the data from a table. Learn all these things. These basic things are enough. And how to create a stored procedure. All of you know, right? What is a stored procedure and all? And how to create a function. Okay, and how to execute a function. Just learn all these things. Okay? Then after we'll discuss JDBC. Okay? Just within 4 days, for sure we'll start JDBC. 4 or 5 days at maximum. But by that time, we should be comfortable with all these things. Okay? Then only we can move forward. And once JDBC is completed, we can discuss Hibernate. Okay? How we can use Hibernate to interact with the database. Hibernate is a framework which is one of the hotcakes in the industry related to Java. Okay? We'll discuss that. We'll discuss step by step. But tomorrow, I'm not sure whether I can able to conduct a class in the evening. But tomorrow morning, definitely there will be a class at 6:30. Is it okay for you? 6:30? 6:30 in the morning? We'll have a class at 6:30 in the morning, and then I'll post on Facebook whether it is possible. Depends upon my work in the office. Okay, I'm not sure about that. Okay, if there is less work in the office for me tomorrow, definitely we'll have a class at the same time 8:30. Till Sunday, we'll have alternative evening as well as morning classes to compensate the loss that we had for the previous days. Okay? That's the plan. Let's assemble 6:30 in the morning. Okay?